Ever pondered why Mars, a planet that's just 53% as large as Earth, has the tallest volcano in our solar system? That's right, Mars, the fourth planet from the Sun, home to Olympus Mons, a volcano 3 times the height of Everest, and Valles Marineris, a canyon system that would stretch from Los Angeles to New York if placed on Earth. It's these peculiarities and Mars's striking red hue that have intrigued us for centuries, sparking dreams of exploring and even inhabiting this celestial neighbor. As humans, we've always looked up at the night sky in wonder, and Mars has always held a special place in our imaginations. It's the only planet in our solar system that we believe could possibly support human life as we know it. Yet despite our technological advances and deepening understanding of the universe, we haven't set foot on Mars. So with the fascination that Mars holds, why aren't we living there yet? Let's delve into the challenges of colonizing Mars. Imagine embarking on a journey that's 140 million miles away from home. That's the first challenge: distance. Now let's put this into perspective. The farthest humans have traveled from Earth is a little over 1 million miles, achieved during the Apollo 13 mission. The journey to Mars is more than 100 times that distance, a marathon that would take around 9 months using current technology. But distance isn't the only hurdle. Mars isn't exactly a welcoming environment. The average temperature on Mars is a chilling minus 80 degrees Fahrenheit, with winter temperatures dropping even lower. That's like spending all your days in Antarctica, but without the comfort of oxygen-rich air to breathe. Speaking of air, Mars's atmosphere is composed primarily of carbon dioxide, with trace amounts of nitrogen and argon, and virtually no oxygen. So humans can't breathe on Mars without assistance. And even if we could somehow survive the cold and lack of oxygen, we'd still have to contend with the radiation. Mars' thin atmosphere offers little protection against the sun's harmful rays, which can damage cells and cause cancer. And let's not forget the Martian dust. This isn't the kind of dust you find under your bed. It's fine, sticky, and gets everywhere, including into machinery and equipment, which could be disastrous for a Martian colony. Then there's the issue of gravity. Mars has only about 1/3 of the Earth's gravity. While this might sound like fun, long-term exposure to reduced gravity can cause muscle atrophy and bone loss. So we're looking at a long, perilous journey to a hostile, inhospitable planet. But as daunting as these challenges might seem, they're not insurmountable. Humans have always been explorers, pushing the boundaries of what's possible. And with every challenge comes an opportunity for innovation and discovery. The challenges are daunting, yes, but are they insurmountable? Certainly not. To traverse the vast distance, we need speed. The solution? Advanced propulsion technology. When we think about reaching Mars, the first hurdle that jumps to mind is the sheer distance. It's not just a hop, skip, and a jump away. Mars is, on average, about 140 million miles from Earth. With current technology, it would take us about 9 months to get there. But what if we could cut that time in half, or even more? Enter advanced propulsion technology. We're talking about things like nuclear propulsion, which could potentially cut the travel time to Mars down to just a few months. This isn't just the stuff of science fiction. NASA's been exploring the possibilities of nuclear propulsion for decades, and recent advancements have brought us closer than ever to making it a reality. But speed isn't the only factor to consider. There's also the question of how to keep astronauts healthy and comfortable during the journey. That's where the concept of in-flight habitation comes into play. We're not talking about cramped quarters and instant meals. We're envisioning habitats where astronauts can exercise, grow fresh food, and even enjoy a bit of leisure time. After all, a happy astronaut is a productive astronaut. And let's not forget about the spacecraft itself. To achieve these faster travel times, we'll need spacecraft that are more efficient and more powerful than anything we've built before. This might mean spacecraft that can harness the power of the sun or even the atomic forces within matter itself. As we stand on the brink of this new era of space exploration, it's clear that the journey to Mars will be a test of human ingenuity and perseverance. But with advancements in propulsion technology, in-flight habitation, and next-generation spacecraft, we're bridging the gap between the dream and reality of reaching the red planet. Speed is just the first step. Surviving on Mars is the bigger hurdle. Welcome to Mars, a planet with temperatures that can drop to minus 80 degrees Fahrenheit. It's a harsh, inhospitable world, but one that we humans are determined to conquer. But how do we survive in such an extreme environment? Firstly, we have terraforming, a sci-fi concept turned real-world solution. This is the process of deliberately modifying the atmosphere, temperature, surface, and ecology of Mars to be Earth-like. It's a long shot, requiring advanced technology, resources, and time. Lots of time. We're talking about a project that could span centuries or even millennia. But if successful, terraforming could turn the red planet into a second Earth. But what about the here and now? Well, we've got artificial habitats. These are pressurized structures which can provide a livable environment within their confines. They could be set up as individual modules, like space-age tents, or connected together to form larger communal living areas. These habitats would have to be incredibly robust, designed to withstand Mars's extreme temperatures, dust storms, and radiation levels. Now, what about when we step outside of these habitats? Well, we'll need state-of-the-art spacesuits. Think of them as wearable habitats. These suits would need to protect us from the harsh Martian environment, provide oxygen, and maintain a comfortable temperature. They would also need to be flexible and lightweight, allowing the wearer to perform a range of tasks, from exploration to construction. And let's not forget about the habitats themselves. They will need to be self-sustaining, capable of generating power, recycling waste, and even producing food. Technological advancements in these areas are vital for our survival on Mars. Surviving the conditions is tough, but what about the essentials? Air, water, food. That's the next big challenge of living on Mars, and it's one we'll tackle in our next episode. So, stay tuned as we continue our journey to the red planet. Breathing on Mars isn't as easy as it is here on Earth. It's a barren landscape, devoid of the oxygen-rich air we take for granted. But fear not, because science has a plan. Generating oxygen on Mars is one of the first challenges we need to tackle. NASA's Perseverance rover has already made strides in this area with MOXIE, a device that can convert Mars's carbon dioxide-rich atmosphere into oxygen. Think of it as a tree absorbing carbon dioxide and releasing oxygen, but instead, it's a high-tech piece of machinery doing the job. With further development, we could potentially have large-scale oxygen farms providing breathable air for future colonists. Now, let's talk about water. Mars is a dry planet, but not entirely waterless. The polar ice caps and underground reserves could be sources of water. However, transporting it could be a challenge. The solution? Recycling. Similar to systems used on the International Space Station, water recycling technologies could purify and reuse every drop of water in the colony, from shower water to sweat. So we've got air to breathe and water to drink. But what about food? Mars isn't exactly known for its fertile soil. However, scientists are exploring ways to grow crops on Mars using hydroponics and aeroponics, techniques that don't require soil. These systems could allow colonists to cultivate a variety of plants, ensuring a steady supply of fresh food. In addition to these, energy generation would be crucial. Solar panels could harness the sun's energy, and nuclear power could provide a reliable backup for when the Martian dust storms roll in. The concept of a self-sustaining colony also extends to creating a sustainable social and economic system. It's not just about survival, but also about thriving, creating a new society where humans can live, work, and explore the vast Martian landscape. Creating a self-sustaining colony on Mars isn't a distant dream, it's a future reality. And with each scientific breakthrough, we're getting closer to turning the red planet into our second home. Mars, the next frontier for mankind, is within our reach. As we have journeyed through the complexities of Martian colonization, we've explored the daunting challenges and the innovative solutions that are shaping our path to the red planet. From the vast distances and harsh conditions to the creation of self-sustaining colonies, the undertaking is colossal but not insurmountable. Our tenacity as a species, our thirst for knowledge, and our boundless capacity for innovation are fueling this grand endeavor. Ambitious projects from international space agencies, private companies, and scientific communities worldwide are converging to make this dream a reality. We stand on the precipice of a new era, a testament to human resilience and ingenuity. The future of Martian colonization is not a question of if, but when. And as we gaze at the crimson sphere in our night sky, we can't help but feel a sense of anticipation. The challenges are real, the solutions are emerging, and the future, it's red. Don't forget to like, subscribe, and share your thoughts in the comments.